Okay, please open the newspapers. So, anything important on the first page? Vice President. Okay, so Vice President Jagdeep Dhankar, right? He has resigned from his position of Vice President. Is it important? Is the post of Vice President important? From which country did we borrow this kind of office of Vice President? USA? UK? Just because there is UK from which we have got many things. That doesn't mean for everything UK will be answer. We've taken this from USA. In United States of America, they also have this Vice President position. We also have similar position. Speciality is Vice President, who is supposed to become President when the President is not available. Let's say President died or resigned or something happened. In that case, for 6 months, maximum 6 months, Vice President can act as President. But that doesn't mean he will become President completely. His position will remain Vice President only. For 6 months, he's acting as President. In case of USA, it is different. If the President of USA dies, then for the remaining term of office, the Vice President becomes President. Okay, that's the difference. Now, we are saying somewhat the similar position is there because the Vice President in India is ex officio Chairman of Rajya Sabha, right? That is, he or she will head the Rajya Sabha. Same is the case with USA. USA has got their Rajya Sabha, which we call as Senate, and the Vice President heads that Senate. Okay, that is the similarity. Now, basic things that you must be aware of anyway. This is something you read as part of your static polity. Article 63 to 71. These are the articles wherein you deal with Vice President position. Now, first of all, it is the second highest constitutional office. So there is a table of precedence given. Who is the highest body or highest person in India? Number 1 will be President. Second number will be Vice President. So understand, constitutionally, this is second highest office in India. Okay. Now, how do we elect Vice President? Yes. So we take the voting only from Lok Sabha and Rajya Sabha. That is entire parliament. State assemblies will not be involved. In case of presidential election, state assemblies are also involved. But Vice President, no. Now here, members of both houses, specifically elected members as well as nominated members, both are going to vote. Again, compare it with President. In case of President election, nominated members are not there, only elected are there. Okay, you have to remember in comparison, then only you will have clarity. Otherwise, in exam, it's very easy to confuse you people. Okay, then how the voting takes place. So there is something called proportional representation and single transferable vote, or in simple terms, if I have to say, the voting will not be of the kind which we see in our Lok Sabha elections, wherein we go and vote one person or one party. Here you're going to, or these MPs are going to vote multiple people. Let's say 3 people are standing for election of Vice President. So let's say you are MPs. So what you will do is, you will give preference number 1 to someone, preference number 2 to someone, 3 to someone. Okay, and there will be a quota of votes. Let's say the quota is 50 votes. So if someone has got 50 votes, he'll become Vice President. Let's say nobody has got 50 votes. In that case, what we will do is, out of 3, whoever has got the less number of votes, we will delete this candidate, and his votes will be transferred to these 2. Getting the point? So that's how we go for Vice Presidential election. Then what is the qualification? Obviously, citizen of India. We can't make American person to Vice President of India. 35 years of age and eligible for Rajya Sabha. He should be having the qualification which is required to become the member of Rajya Sabha, not Lok Sabha. Okay, and he is not holding any office of profit, any office in central government, state government, or anything. He should not hold. In case he is member of some body, let's say he is already member of any house and all, that seat he will have to vacate, or that will become vacant as soon as he becomes vice president. Okay, his term is for 5 years. Now in case of Jagdeep Dhankar, he has resigned before completing 5 years, so 2 years are still left, but he has resigned. Okay, now is vice president eligible for re-election? Can he get re-elected again next time, or there is a barrier, only once you can become vice president? Nothing like that, right? We don't have any such provision as such. For president also we don't have, vice president also we don't have, prime minister also we don't have, right? So there is no barrier as such. Oath to this vice president is given by President of India. These are the facts you should be aware of, at any cost you should be aware of. Then how do we remove this person? This process is different for every office. As far as vice president is concerned, if you want to remove him, you have to bring a resolution in Rajya Sabha. Firstly, you have to bring resolution in Rajya Sabha. You can't bring it in Lok Sabha. Okay? In the Rajya Sabha, you have to go for something called as effective majority. Now, effective majority simply means, let's say there are total 245 members of Rajya Sabha, out of which, let's say, 5 seats are vacant. 5 seats are vacant. So in reality, how many seats are there? 240 only. So out of 240, you need 50%. The majority of this membership, wherein we have removed the vacant seats, that majority. So 240 half is 120, you need 120 numbers. That majority is needed in Rajya Sabha. Once this resolution is passed to remove vice president in Rajya Sabha, then you will go to Lok Sabha, and there you only need simple majority. Simple majority means whatever number of people are sitting, only 50% votes are needed. We are not talking about membership of Lok Sabha. Only people present. Getting the point? So that's how you're going to remove this person. And the first vice president was Radhakrishnan. Anyway, we know. What about this person? He was the 14th vice president. Just basic fact you should be aware of. Clear? Done. This I consider as one of the most important news. NISAR, first joint satellite of NASA and ISRO, scheduled to be launched on July 30. Any idea about NISAR? What is NISAR, the long form of NISAR, or anything? Is it Indian project, American project, Chinese project? Maybe here I'm just looking at NASA and ISRO. So yes, NISAR. Now this is an important mission. NISAR, the name means N for NASA, I for ISRO. NASA and ISRO are collaborating. Okay, collaboration is there to develop something called as SAR, synthetic aperture radar. Okay, now basics first. We need to know what is this radar. Any idea what is radar? Huh? Detects what?
Radiation.
Detects radiation. Okay. Heavy radiation. Okay. Now simply we say that radar is a system, let's say some devices we have developed, through which we can check if there is any kind of radio wave coming. Now those who do not know radio wave, simply understand, from sun we are getting lot of energy, right? Lot of energy is coming from sun to earth. Now this energy comes in the form of waves. We call these waves as electromagnetic waves. Okay, basic energy is coming in the form of waves. Now these, we call them electromagnetic because it has electric as well as magnetic field. That's very technical part, you don't need to worry about. But electric and magnetic field is involved, that's why the name is electromagnetic. And these are waves. Now waves simply, now here you can see, these are the waves which you can observe. Now some waves would look like this, right? Very close, means let's say this is the wave. Same wave I can make in this manner. Can you understand? So look at the length of this wave and look at the length of this wave. The same wave, but length is getting reduced over here. Can you tell me where the energy would be higher? This is number 1, this is number 2. For this, can you imagine this idea? Energy is coming in the form of waves, right? So just imagine this area, this much area. In that I can give you one wave like this, or I can give so many waves like this. Where do you find more energy? This one. So where the wavelength becomes less, that means the energy is very powerful. Can you understand this basic part? Where the wavelength is long, wavelength you can understand, the length of the wave, that is long, that means the energy is very less. Clear? Now look at this. Whatever energy comes, some part of that energy will have long wavelength. Yes, please look at this. Whatever energy comes to us, some part of it will be having this long wavelength like this, and some part will be having short wavelength. Short means very powerful energy. Okay? Now, depending on its wavelength, what scientists do, they give the name to these waves specifically. So this kind of wave is called as gamma ray. This kind of called as X-ray, ultraviolet, infrared. This smaller part over here, only this much, that's called as visible light. This one, microwave radiation, and last is radio wave. So radio wave will have the intense energy or less amount of energy? Less, common sense. And gamma rays? Highest. So if I let's say somehow if I take some gamma ray and just put it on you some way, so everything will be gone. Simple, basic. Or radio waves, nothing will matter as such for you. Now you see, this is the area where I'm talking about visible light. And this is the light which you can see. This is the light because of which we all can see things. Other lights we are not able to observe, but they are there. You can't see, that's a different thing. Okay? Now out of all these, just look at radio waves. We can't see radio waves, but we can detect that using some system, some device. We can even detect X-ray, gamma ray, all that, even if we can't observe it directly through our eyes. So to detect radio waves, the system that we have is called as radar. Yes, clear? It's called as radar. Any doubt on this? No. Now, radar, the long form is radio detection and ranging. That's the long form we have. Now, what happens is, when we send our satellites, what we are trying to do, we are trying to observe Earth. Most of the satellites are sent so that we can observe Earth. Let's say somewhere volcanic activity is happening on a mountain. You can't go directly physically and check that, right? You can't even install any camera there because the temperature is so high, the camera will be like melting. So what you can do is, you can have a satellite in the space and that satellite can observe it. One way is you take normal images, but normal images can only be taken for visible light. If there is visible light, let's say you remove the visible light, you can't take these normal images from our camera, right? But if you don't check visible light, we have these other lights also, right? Other spectrum or other radiation, like X-ray we have, gamma rays we have, radio waves we have. So one way would be to have one kind of device or camera, something which can detect these waves, through which it can check what is the object over there. So let's say we have a satellite over here. Okay, just consider it's a satellite. And let's say here you have a mountain. Okay, it has to observe this. What this satellite will do, it has a device which can send some radio waves. Okay, those radio waves will come here, then collide to this region and go back. Okay, similarly here also. So this kind of thing will happen, and with this collision and it comes back, the receiver will be there on this device over here. It will understand what kind of object is there. Are you getting the point? It can tell you exactly, it can make the image, what exactly is there. Fine, that's what is happening in terms of these aperture radars. Now what's the core difference between a normal radar thing and this synthetic aperture radar? So when you say synthetic aperture, what you are doing? In any of this radar system, what it is trying to do, make some image, take some image. Now image, normally when you take any image from a very long distance using your camera, the image will be having very low quality. Now you want high resolution image. For high resolution image you need bigger camera, DSLR or something bigger system, right? Similarly, when it comes to radars, they need antennas of larger size. But when you're sending satellite, that's not possible for you sometimes to have such a larger system in the space. What you will do right now is, you have developed a new technology which we call as synthetic aperture radar. It will simply do one thing. It will keep on moving continuously. Let's say it has to check this one object over here. So it will take the image. It will take the image of only this part. Then it will move and it will take image of this part, then this part, then this part, this part. Likewise, it will take so many images and then it will mix all that and make one entire image. So small images of small parts, then all will be merged together to form that larger image so that we can get high resolution image. Now are you getting the point? This is synthetic aperture radar. Very different from the normal radar systems that countries are having. Okay, this is a new technology. Clear? Any doubt? No? Now see, going further in the technicality, there is something called as dual frequency radar, or the radar which we are using over here, it has dual frequency. You should know these technicalities because I personally think this is a very important topic for exam. Dual frequency. So here, this radar system, it will have different frequencies. There will be different ranges. So you have channels in your television sometimes. They are running on different frequencies. So similarly, here also, radio waves will move in different frequencies. So there is a band. There is, let's say in this band, some waves will go. In this band, some waves will go likewise. Now some waves will go. Some waves will be long wavelength waves. Some will be short wavelength waves. See the difference now. Let's say we have L band and S band waves. L band means those will be long waves. S band means those will be short waves. Now remember, short waves are powerful one. Long waves are not so powerful. Now see the difference. Long waves, they can get into the forest and soil. This is their speciality. When there is a long wave, it can penetrate even inside your forest and get deeper. It can go into the depths and give you details. Okay? So if you want details in depth, this L wave is going to be very helpful, or this L band is going to be helpful. Whereas this shorter wave, it doesn't go deeper. It can just go for the surface area. So normal surface area, this S wave will come and it will just go back. So if you want really good image of the surface level area, you will go for shorter waves. If you want very detailed and deeper images, in that case you need longer waves. And this synthetic aperture radar or NISAR project, it is using both of the bands. So now whatever images we will have of the Earth's surface, those are going to be very detailed and we are going to get details of each and every part of Earth. Okay, now you will understand the application better. So now just get back. Don't worry about that technical part. Just remember there are two bands. They'll not ask in detail. I'm just telling you those details. Okay, L band and S band, just that's it. Now you'll understand. See, what will be the use of this radar? First of all, it works day and night in all weather condition because we are using radio waves, and radio waves can go even if there is cloudy situation because they can move into the clouds also, no problem. day and night, any time you can use it. So 24/7 you can go for surveillance, you can get images, you can know what is happening, where it is happening, everything. Yes, very helpful even for military, very helpful even for our civilian use. Let's say there's a disaster taking place, there also it becomes useful. Then high resolution images, very high resolution images. So this is the speciality. Minute surface movements. You can imagine, even let's say you are moving over here, not here exactly, on the, let's say on the terrace. So even that can be captured very easily. Even they are saying the details are so minute that even if something is moving, something is very smaller on the ground, even they can detect that. Such a high resolution image is provided. So very good. It penetrates vegetation and monitors deforestation and agriculture. So deforestation is a big problem right now. Forests are being cut and we don't know where and when. So now just go and check the images online and you'll get to know what is happening. 24/7 again, day and night, every time you're going to get those details. Okay? Then it can track floods, glaciers, what is the rise of sea level around the world. And because, see, minute details are there. Even if there is some rise, let's say 0.5 centimeter rise or 1 centimeter rise or something very minute, that can also be tracked. Same for earthquakes, landslides, volcanic activities, infrastructure stability like bridges, dams. If there are any problems, you can observe that. So now you can understand why we needed those different bands. Okay, so it has large scale application. Okay, just remember this part, said that it is not made for just one particular cause. It will have large scale application. Yes, any doubt? Just basic, let's just check if we have understood or not. Do you know what is radar now? Do you understand what is radio wave? Do you feel that you understand? At least you should feel. Yes, radar you understand? Yes, 2 bands are being used over here. L band, S band, done. Okay, that's enough for you right now. Done. This is NISAR project. We are working and this will be launched soon. And this is a good collaboration between ISRO and NASA, which is happening for the first time. Such a collaboration is happening for the first time. This is somewhere we can say that ISRO has come to a good level now, wherein NASA and ISRO are at equal state. Or rather, ISRO is ahead. NASA came and said that we will have this partnership. Otherwise, India will develop something very big. Okay, that's all. Moving ahead. Next news item. Index of 8 core industries grew at 3-month high of 1.7% in June. I think it should be on business page. So any idea about what are these core industries? Do you think they will ask such filthy question about core industries and all? Yes, is it important? Huh? Maybe. Yes, good. So they're talking about something called as core industries. We should understand what do we mean by core industries. So there is an index in which we specifically talk about our manufacturing sector. Okay, our manufacturing, our industrial sector. We check what is the growth, what is happening in our industries. Now in that we will have different segments of industries, different sectors, different industries will be part of it. Steel industry, aluminum industry, all these different. Now out of that, if we check all these, we have one index called as Index of Industrial Production. Okay, this is released by Central Statistical Organization under Ministry of Statistics. So just remember, MOSPI, Ministry of Statistics and Program Implementation, from which we get this index. Now in that, we have all the data for our industries. Now even in this data, if you check 40% of the weight is given to only 8 industries. Only 8. And those we call as core industries. Okay? So for them also we have a different index altogether. Now, for that we have this index of 8 core industries. Now because they have got 40% weightage, this simply means these are the most important industries when it comes to manufacturing sector in India. We are trying to check the performance of these industries. We are not checking all industries, but we are checking the performance of these industries because their performance matters more than others. What it includes: refinery products, electricity, steel, coal, crude oil, natural gas, cement, and fertilizer. And there's a different weightage given. Highest weightage is given to refinery products and least is given to fertilizers. And unfortunately, you will have to remember these things. Okay? Unfortunately, they ask such minute details also. Okay? So please focus on this part. Who releases this list? Office of Economic Advisor under Ministry of Commerce and Industry. Every month you will see the same news which will show if there is growth or it is declining, what is the trend. They will talk about the trend. So every month we will definitely get this news. Okay? So this is something you will have to memorize, whether you like it or not. Now the news. They're simply saying there is some growth in some industries and there's some decline. For example, there's growth of 5.1% in June 2024, and there is this 1.7% growth in June 2025. The top performers over here are coal and cement. So simply, coal and cement industries are doing good. And there are some who are doing bad, like crude oil, fertilizers, electricity. They have mixed or negative growth. That's it. Just look at the trend, what is happening, and just leave it. More than this trend right now, because it is monthly trend, which is going to change. Okay, just have a look at it. You'll find it interesting what is happening and all. Okay, this is important. Any doubt? No? Now next one is water energy demand spotlights risk of human induced quakes. Is it there in newspaper? No, in the soft copy only. Now here the article specifically talks about human induced quakes. Quakes means earthquakes they are talking about. Now earthquakes, why do we see earthquakes? Any idea? Is there a natural reason, or we people do something because of which earthquakes are coming? Naturally it happens, right? Just now we got the news today only that there was some kind of earthquake or some tremors in Delhi. So Delhi, every single day we get this news. You're sitting on a laptop in Delhi and sometimes you feel something is happening like this. It's a natural reason. Yes? You'll understand why it happens, that natural reason, when you study geography in detail. Now the point is, sometimes earthquakes happen because we people do something. That kind of earthquake is human induced earthquake. Human induced. Human have caused this earthquake. Okay. So for example, what we do, sometimes we go for mining activities, or sometimes we build some reservoirs. Let's say we have built a dam. Let's say this is the river and here we built a dam. You have built a dam. Now what you're doing is you're not letting this water go. So the water level will increase. It will become like this. Let's say so much water is there. This water will apply a lot of pressure over here in this area. And because of that pressure, many a times we see earthquake in this area. Okay. This is just one part. This is happening because of this dam, or we call it as reservoir. Because of dam this is happening. Sometimes such things happen because of mining. Or let's say you're building a tunnel. Let's say in Jammu Kashmir or some mountainous region, there you're building a tunnel. Now because of construction of tunnel, or sometimes you go for some activities wherein you are trying to add some liquid in the earth's crust or the area. What happens is, because of that liquid, some kind of fractures are developed in the earth. Okay, we want to do that. Let's say there is some kind of natural gas or oil or some kind of resource we can find out in this particular area. So we want to get that, we want to do mining, or we want to do something. Now for that we go for such activities. But as a result, we see some earthquakes later on. That's the same simple thing this article is talking about. So if we check, they're specifically talking about the key causes why this human induced earthquake happens? One of the reason is reservoir induced seismicity. Reservoir, simply the dam, because of reservoir. Best example is this Koyna Dam. There was earthquake of 6.3 magnitude and it is very high. 6 magnitude means it's a very dangerous earthquake. Okay, that we saw in Maharashtra on this because of Koyna Dam. Okay, then groundwater extraction, because we are taking a lot of water from this groundwater which is available, and groundwater table is going down. Because of that, there will be changes in the geological structure that is there, and because of that, suddenly some energy will be released in the form of earthquake. So any kind of pressure building in the earth's crust, any kind of energy being released, that will lead to earthquake. Okay, this is one thing. Then mining and oil extraction, this is one thing. And fluid injection, which I talked about, some kind of fluid you are putting, which leads to this process of fracking, or the same thing, kind of fractures developing. We want those fractures to develop for our economic reasons, but it is leading to these human induced quakes. And you see this data. This is important to understand the importance. In last 150 years, we saw 1,200 earthquakes because of humans. These are not natural earthquakes, they are talking about human induced earthquakes in last 150 years. Okay, now understand one more thing. Here this role of energy demand and water demand is very high. Why we are going for that extraction, those mining activities and all? We need natural gas, we need oil, because our energy demand is very high. Population is very high, our electricity consumption is very high, and for electricity or for our transportation, all those things, we need energy supply, we need oil, we need coal, we need all those things. Because of this high energy demand, and continuously it is increasing, it is not even reducing. Because of that, we are going for such actions leading to earthquake. One. Second is the high water demand. Because the demand for water is increasing, because of that, we are going for pumping more water. Demand is increasing, reasons are different. Somewhere, let's say for our drinking purpose, we need water. Somewhere for agriculture purpose, we need water. Somewhere for industries, we need water. There are different reasons. And because of this increasing water demand, again, can you see the linkage? How energy demand and water demand is leading to earthquakes. This is the linkage this article is trying to give you. Simple. Yes? Someone was asking me last time how to read newspaper and all. So I just wanted to say this one thing. From this entire article, if you can grab this one line, okay, even if you don't see this, there is role of water demand and energy demand in causing human induced earthquakes. This is the one line. Can you understand this one line now? That's what you're supposed to get when you read this entire article. The entire article is given so that you understand it. Once you understand, you have to just remember this one line. That's it. Your work is done. Okay? That's how you read newspapers. Simple. Yes, any doubt? No? And the last, this one is a good article. What is the legal status of right to vote? Although I had discussed about right to vote earlier. Still, if you people have confusions, they've given so many cases in this article. So in one case, the court said right to vote is a statutory right. In some other, they said it is not a fundamental right. Some other, they said it's not fundamental, but it is constitutional right. So many cases are there. In majority of the cases, it seems court is saying it's a statutory right. Statutory right, right? Statutory means we're deriving this right from a statute or a law, not constitution. Okay? But some judgments are saying the basis of this statutory right is constitution. Okay? And in one of the previous year papers, you will find this question also. Right to vote is which kind of right? UPSC had once asked, and they had confused a lot. That year it had become a case of debate because there was legal right as an option and constitutional right as an option. Okay, such questions we can't do anything. Answer given by UPSC was constitutional right. Okay, but this complication is there when it comes to this right to vote. We can say yes, it is statutory right. Yes, it is constitutional right also. We'll accept it. Okay. So because we don't see the consistency. In some judgments, they are also saying there is constitutional backing. Okay. So that's it. Done. Any doubt? No doubt? Then we are done. Thank you so much.